Best practice means the best way of doing something. Of course, it might not be the same for every person, but it's important to develop a set of standards that you and your colleagues are going to follow, particularly when using FME, and that's what we're going to be talking about today. You might wonder, why should you use best practice? What's the benefit here? So for me, I think the reason is to make life easier for the people who will inherit your workspaces. That could be other people that work in your organization who use FME. It could be your customers if you're providing workspaces as part of your job. And it could also be yourself several years down the line, opening up an old workspace and being like, what was I doing here? Best practices can help answer that question. In addition to helping yourself out later down the line, we'll also teach you some skills for helping yourself as you build your workspaces, to have a clear methodology and some skills for debugging so you can quickly develop effective workspaces and identify problems as they come up rather than later down the line when it might be too late. So in that vein, we have 3 different sections we'll be covering today. The first is on debugging, so trying to find and fix problems as you build your workspace. Methodology, which is basically how to be efficient while using FME. So we'll talk about performance, how do we get a workspace that will run quickly. And we'll end the day off by talking about style. And this is what we have found are good tips and tricks for keeping your workspaces organized so that you and others can understand what they're doing. Again, none of this is really set in stone. This is a little bit more of a subjective day, based a lot on the experience of the training team working with FME in some cases for quite a while. So we have picked up ways to effectively design workspaces, and we're going to try to share those today. But you can just pick and choose whatever works for you, really. So let's start off by talking about debugging. I find it's really useful to run a workspace often. You want to find out if something's going wrong sooner rather than later. It's easier to debug if you only have to look in a few places rather than search the entire workspace for the problem. So an important piece there is to debug in the correct order. When things go wrong, and they probably will, the first place to look is the log window. I usually look there for any obvious issues. You can check the feature counts on feature connectors to see if they look correct. And you can use feature caching to inspect the caches as you build your workspace to make sure your data is in the right form that you're expecting. So as you're doing this, the order you should probably do things would be check for a problem, interpreting the log, locate the problem, so you can look at those connection counts or caches, and then determine what's actually happening. So that usually involves looking at parameters, maybe opening the data up in Inspector and trying it out, or even in the native application that you're trying to use it in and seeing if it looks correct. Starting with the log window, there's 4 kinds of messages that you could encounter in the log. And it's important to know what these are so you can kind of interpret what's happening. The most obvious would be an error. It's denoted in the log by red text, and it has this term error in all caps. That's a pretty obvious one. That will mean that your translation was unsuccessful, it wasn't able to actually finish. So those are usually pretty obvious and imply a major problem. A warning in blue text and with the term warn means that something should be looked at more closely, but the translation will still run to completion. Warnings are usually safe to ignore in the long term, but you should always investigate them first and make sure that they are to be expected with your workflow. Sometimes you'll see things that there's just an attribute that has the wrong case, or maybe a coordinate system is being applied, and those could often be safe to ignore. But if there's a warning that says that a feature has the incorrect geometry type, that could be more serious. That might be a problem with how you've set up your workflow. You expected you were only getting points, but you were actually getting points and lines or something like that. Information lines or inform will tell you a piece of basically information that's happening at that point in the translation. And the stats or statistics line, those will tell you how many features have been read, written, or transformed. So they're good just to get an overview of what happened. It's also worth noting that the log, every time you run, is written out to a .log file, which you can just, it's just a plain text file you can open up with any text editor in the same folder as the FMW file. And there's also a FFS file, which is a FME feature store format, and that stores any features that are mentioned in the log, whether they were warnings or used a logger transformer, if they were rejected, anything like that. If a feature is mentioned in the log, it'll be put into this file. And so that can be good to do some debugging. If you know that the issue is coming from a warning or a rejected feature or something, you don't have to go find it in your workspace if you don't want to, especially if you have a large workspace. You could just open up this FFS file and immediately see the problem features. So for interpreting the long window, I've kind of already basically said what you need to do there, but basically you should check the log after every translation. First thing you should look for is errors, of course. Those will be obvious. They'll be red text and the translation will fail. But it's always good to look through and find out what the failure was and try to follow the breadcrumbs, so to speak, to go find the issue. So this one here, example in the manual, is that there was an error connecting to a database, and it just says that authentication failed. So that's a pretty easy one. You know, if you get that error, you just have to go make sure your credentials are correct for that connection. And then warnings, like I said, usually a good idea to check them the first time they show up and make sure it doesn't imply that there's something wrong with your workflow. But after that, you can usually safely ignore them. It's important not to just inspect the final output of a translation and then assume that any problems occurred during the transformation process. Sometimes the problem will actually be the source data or how FME read and interpreted the source data. It might actually not be the transformers you're using, for example. Sometimes the problem could actually be with the writer as well. Maybe it can't handle some property of the feature that's being written. If it has a restricted schema and you're giving it features that don't match that, or it can only handle one geometry type and you're giving it multiple, something like that. So you can always sort of look at the output and ask these questions, if it's in the right format, if it is in the right structure, if the attributes are making sense to you. That's always a good stage, but you don't have to only inspect the output. Sometimes what you're seeing is going to be relevant before then. Feature counts are also a really useful debugging tool. If you see features going into a transformer, but nothing is coming out, then there's very likely an issue with that transformer settings. And you can also just debug more generally using feature counts by looking for an incorrect number of output features. You can also check to see if any features were rejected, which could be a problem. So in this case, the example shown here in the manual, we've got 6 features coming in from this neighborhood feature type and 80 coming in from this attribute manager into a clipper. But it looks like there might not be anything coming out of the clipper, so that could be a pretty obvious problem. And if the output was wrong in some way, you could go back and check the numbers here to see if any features were being lost or you couldn't account for any. If the number is incorrect, you can check a couple things. Of course, make sure that there are features entering the transformer if none are coming out. Or check which port they're coming out of. So here we were expecting 80 or some number anyway to be coming out of the inside port, but they're actually coming out of the outside port, which means that they don't overlap at all, which means they can't really be clipped. So something's going on there. It could, for example, be that they're not in the same coordinate system. And another one, I've had this embarrassingly mess me up a few times, is that you just connected the wrong port. This happens, you see people do this sometimes when they're first using the statistics calculator transformer, which has 3 output ports. If you want to maintain all of the features you had going into the statistics calculator and just add the statistics on as new attributes, you need to use the complete port, and that will give you the same number coming out as went in. But the summary port only returns the summary statistics that were calculated, just the mean or the sum or whatever. And those will just come out as a feature for each statistic. And so here, of course, you can see we have 6 coming out of the sum report, 6 features coming out of the sum report versus 80 coming out of complete. So if you hooked up that sum report by accident, not only are you going to have the wrong feature count, you'll also have a bunch of missing attributes. So it's usually clear something is wrong, but sometimes you'll miss it because you'll be like, well, I set up the parameters of my statistics calculator correctly. I know that. You might just have the port messed up, the wrong port selected. And an additional thing to check with feature counts is rejected features. Sometimes if you notice your feature counts are not right, if you're expecting there to be more features than there are, a likely culprit would be rejected ports. These are where any invalid features will be routed coming out of a transformer. So you'll see that, for example, here we have an example with the donut hole extractor. You'll see it quite often with a clipper. Any spatial analysis, you'll often see rejected ports if you're working with data that doesn't, for example, doesn't have geometry, it might get rejected, or for some other reason. And so that's a good place to check if you're missing features. And of course, with the feature caching on, you can just click to inspect and see why those features were rejected. And finally, rejected features usually have a rejection code attribute, which you can check out, FME rejection code, and that will tell you why it was rejected. So in this case, for the donut hole extractor, it was an invalid geometry type, and that's why it was rejected. Sometimes it can be tricky figuring out exactly when a translation went wrong. So it's important to check if the data was read incorrectly, transformed incorrectly, written incorrectly, or if the data was incorrectly interpreted by another application. So that's to say, there are several stages where your translation could go wrong. And so you shouldn't just assume, I think a lot of people would tend to assume that this stage, the transformation stage, is really where all of the problems lie, and maybe the majority would, but these other stages can be just as important. So it's important to check those stages if you're running into problems. So we have a little example in the manual here. I'll just walk through quickly to do with encoding. So in this example, we have an address geodatabase with some postal addresses from the city of Vancouver. And some of them have non-English characters. Here we've got some Chinese characters, and you can see that they're encoded properly if you view them in ARC catalog. And so that's an important thing to do. You can view the source data to make sure the encoding looks correct. And then you can expect it after it's been read in FME and it looks like that's been preserved properly. And you can inspect it before writing. So this would probably be the feature cache directly before you are writing out. And you can ensure that encoding looks correct. But then in this example, if we were writing out to CSV, depending on the encoding we selected, we might end up with these question mark characters showing that there was a uninterpreted character. And so here we've got a problem, and the problem is arising in the actual written data itself. And you can double check that by, in this case for CSV, just opening up in a text file to notice that those question marks are present. So there's something going wrong with the encoding. You can double check if you want and look at a different application. Here we've got an Excel. Or you could open it back up in a geodatabase, for example, to see if it was working. So that would be one way to narrow down where the error occurs, check all those key stages. And then in this case, it was obvious it was an encoding problem, and it was obvious it was at the writing stage. The encoding was correct up until the data was written. And so a good place to check in that scenario would be your writer parameters. And if you look at if we were to look at the character encoding parameter for this output CSV, you'd see it's just in the wrong encoding. And so you could change that. So those are some best practices for debugging, different ways you can go through and test the different stages of your translation to find out where problems are occurring. And we're going to basically do some of that with a not super well designed workspace. For part of this exercise, we're going to try to improve it and do some debugging to find out what might be going wrong. And that will kind of be the overall theme of these exercises for today, is to work with this workspace that calculates the walkability of each address in the city of Vancouver. And we're just going to help debug and clean up and apply best practices for style, particularly to this workspace to improve it. So as I said, the scenario is walkability. Many of you are probably familiar with this term. It's basically the idea of measuring how walkable amenities are to a given location. And so we're doing a sort of version of that here where we're reading in all the addresses in the city of Vancouver, and we're taking into account their level of crime in the proximity of the address, their walking distance to the nearest park, and their presence in noise control areas. And that will give us we can use those different data sets to get a measure of walkability, which is usually measured on an index. So we have that workspace sort of set up, but it doesn't currently measure overall walkability. So what we're going to do in this exercise here is we're going to open up the workspace at this point, and we're going to try to add a measure of walkability. And as we go, I'm just going to point out some ways you could debug as you're doing this sort of procedure in a workspace. So to start off, let's open up the pre-existing exercise workspace. I will chat out the path here, and then I'll just show that to you. So everyone probably on day 5 by now is familiar with the structure of where everything's located, but just in case, some of you might not have been using these very much, so I'll show you one more time. If you want to access the begin and complete workspaces for the exercises, you can open up your file browser. You can click on this PC, and then the C drive, FME data 2019, workspaces, desktop basic, and we are looking for best practice exercise 1 begin. There it is. And a couple things to note here. So for one, depending on your machine, we did have some issues with these best practice exercises. So we did actually reboot the machines and add these exercises last night. So they should all be working correctly. If you run into any errors while you're opening these up, please let us know in the questions panel and we can help you out. The other thing to note is, again, depending on your machine, you might also have these FMWT files. Those are template files. We will be working with something similar later today, but we're not going to be opening those at all. So you can just ignore these FMWT files. So when you open up this file, make sure you get the FMW file. It's much smaller, and it just has a FMW extension. So we're looking for best practice exercise 1 begin. So go ahead and open that up once you've found it. And I'm going to set up my screen so we can see both of the windows here. Oh, that's not nice. There we go. I have GoToWebinar running on this machine as well, which can cause a bit of a mirror-in-mirror effect. There we go. Okay, so we'll just let Workbench finish starting up there. I'm going to dock that over here on the left. Okay, so here we are. This is our workspace. It's looking a little messy, as you can see. We'll talk about some of the style best practices later, but you probably already are thinking, ooh, this looks a bit unorganized. There's all sorts of lines crossing over here. We've got lines crossing. Things aren't really lined up, so it's kind of hard to tell. You can probably see already why you might want to use best practices. Someone who doesn't know what this is kind of hard to interpret. We don't really know what's going on. Thankfully, I am familiar with this workspace, so I can tell us what's going on. We're reading in the postal addresses over here, so these are the ones we're going to be using for each address will have a walkability calculation on it. We're also reading in the crime data, which we're joining to our addresses. We're using a feature reader to read in the noise control areas. And we're basically just using some attribute transformers and some overlayers and similar sort of spatial overlay transformers to join all of our data together to get this measure of walkability. And so at this point, we're ready to now calculate the walkability. We're not going to clean the workspace up yet. We'll do that a little bit later. If you hit down the down arrow on the output of our last transformer here, attribute value mapper 2, you can see our schema. The attributes we have right now. We have quite a lot, which is a problem that we'll address later. But you will see some key calculated values here. So we've got park distance, crime value, and noise zone score. And so these are all basically calculated values that are trying to measure how far from a park this location is, how much crime there is there, and how quiet it is based on the noise control zones. So we're going to be using those 3 attributes to calculate a measure of walkability. So let's add a expression evaluator. That's the transformer we'll be using to calculate walkability. So you can click on your attribute value mapper _2. That's at the end of the workspace here on the right, and then just start to type in expression evaluator. Whoops, to add one. So you should have an expression evaluator hooked up to attribute value mapper _2 there. I see someone mentioning, we got a couple questions about the data, which I think I will take some time to address just to make sure everyone's on the same page, because these workspaces or these exercises do require you to have access to these workspaces to do them. So first of all, the FME data 2019 zip file should be updated. So you can just download that and grab the workspaces, especially if you're working on your own machine. Someone else was saying they're only seeing the FMWT files. That shouldn't be the case. If that is the case, maybe sort by type. Check if you're sorted by type. That could be something that's going on, just that if you have it sorted that way, you might not see the FMWs. If you don't see best practice exercise 1 begin as an FMW, that does mean you have an outdated version of the data. And so if that is the case, I would recommend that you just download the zip file and just grab the workspaces that you need. So I've just pasted in chat. This is the link to the zip file, which should be up to date with the correct workspaces in it. Unfortunately, it is a bit large, so you might have to wait a minute while it downloads. But once it downloads, then you can go to, you'll have to extract it to your C drive or just grab out the relevant workspaces, but then you can open that up and find those. Yeah, if you're on a virtual machine and you're not seeing the FMW files, I'm not sure why that would have happened. My recommendation would be, if they're not there, would be to download the zip, and we apologize for those not being present. At this point, it probably makes sense to just get that downloading and find them, and I will continue to work through the exercise, and hopefully you can catch up with us in exercise 2 if you're not able to get it running fast enough for exercise 1 here. Okay, so everyone who has the correct workspace should have added this expression evaluator transformer now. So you can go ahead and open that up, and this is where we're going to calculate the walkability score. For the new attribute, instead of _result, we are going to call it walkability. So you can go ahead and type that in. And then we're going to construct our expression here. If you want, you can just copy it from the manual. I'm going to show you how to construct it in the arithmetic expression area here instead. So to add the values of attributes, you can click the FME feature attributes drop down. This will show you all the attributes on the features going into this transformer. So the first one we want is park distance. And so you can find that towards the bottom here and just double click it to add. And then we're going to be adding that to crime value. So you can click a plus. And then you can find the crime value attribute and double click to add that. And then we're going to do a minus subtract here and find the noise zone score. See another possible solution to the having the incorrect data here. Let me just show that. That was just shared by my colleague Ryan in the chat here. So let me see if I can find that. That's in the C drive. Yeah, so if you want to try to update the data that's on your machine, instead of downloading the zip file, another thing you can do would be to go to C drive, then the temp folder, and there's a FME data download install Windows batch file. And so that will basically get the most recent version that it can of your FME data and try to put it in the folder for you. So if you double click that and run that, that should get you the updated version of the workspace. So that's another thing you can try to do. I'll paste that path. Okay, we're giving you, I see Mark has just also posted that he put the affected workspaces on Dropbox. So if you want to download those from his link in the chat, you can do that. We're giving you a couple different ways. Hopefully one of these will work for you. And again, we apologize if you did not have the correct workspaces loaded up. But there's a few ways now in the chat window where how you can try to get the correct one. Okay, so back to the expression evaluator. This is where we're at. We are getting the value of park distance and adding the value of crime value and then subtracting the value of noise zone score. And the idea here is to get the smaller a result, the better, right? So further from a park is bad, higher amounts of crime would be bad, and a better score in the noise zone score would be good. So that we want a low number here. So once you have that expression like that, you can click OK. And then let's go ahead and run the workspace. This might take a moment. It's going to run through everything here. And in a moment, we can take a look at the result in the expression evaluator. And this will also give everyone a time to sort of speed up. So for the next step, what we're going to do is basically see if we have the results that we expected. And we'll go through that same order that I suggested originally for checking your results. So the first thing to do would be look in the log window for any errors or warnings. You can see we don't have any errors, which is good. And the translation was successful. We do have 136 warnings, which is probably not a good sign. Usually if you have enough warnings you can ignore, there often wouldn't be that many. So we should probably take a closer look at those. You can click the button for where it says 136 warnings to add a filter to your log. This will just show you your warnings. You can also do this for errors. You can do both at the same time as well if you want. So once we filter for warnings, we can sort of scroll through and see what we have. This is fine. We know that we're recording feature caches. But then you'll notice the first major warning we have here is expression evaluator failed to evaluate expression something, something, something plus null minus 0. Result is set to null. And then if you scroll up more, you'll see you have another one of those and another one. So it's looking like part of the issue here is that the expression evaluator is calculating some null values. And so let's inspect our expression evaluator just to ensure that that is the actual problem. You can do that, and we'll scroll over to walkability. This would be the potentially affected attribute. And then we'll right-click walkability and sort alphabetical ascending. And you'll see, in fact, we do have some null values here. quite a few. So something's going slightly wrong with our expression there. For some reason, we're getting null values in our result. So we've identified the problem. We know where it's happening. It's happening in this transformer. At least the warnings are coming from that transformer. So let's find the actual problem. If we look back at our log window, we can get a clue basically, which is if you look at the warning itself, it says fail to evaluate expression, and this is the expression here. It's a real number, so 455, and if we look at our expression, in this case, that would be the park distance. So for this feature, that would be the park distance plus null. So, and then minus 0. So we can see it has a value for park distance and it has a value for noise zone score, but it has a null value for crime value. So we know that that must be the issue. There's a null value for crime value for some of these features. So let's find where that is happening. We'll go back in our workspace to identify where crime value is being calculated and why it might be getting a null. So we can start to organize this workspace here at least a little bit. I noticed someone in the questions panel pointed out you can use auto layout if you want. That is often a good start. And if you had a messy workspace like this, it might not be a bad idea to just hit auto layout and it will move everything around for you. But in this case, I think we'll just do it manually so we can do it kind of step by step. But we can organize this a little bit here. Maybe let's at least get our feature joiner to center point replacer area a little more organized. So I'm going to move these 4 over. And again, you can kind of do this however makes sense to you. I'm just organizing one little section of the workspace for now. And I'm just going to basically put these transformers in a line. Maybe I'll actually do that even a bit more tidy by moving all of these over a little further. And then we can put this in between. So this is a little bit more organized over in this little section now. So let's find out where this null value for crime value might be coming from. A good place to start would be looking at these feature caches for the feature joiner. So I'm just going to click the feature joiner. So everyone should do that. Click the feature joiner and all of your caches will be loaded. This is where we're first getting our crime data. As you can see, we're reading crime data in here on the right. And if we look, this is our joined cache here. And these are all going to be addresses with crime values. If we sort this alphabetically ascending, we see we don't have any nulls here, at least for postal address, assuming you would have nulls for everything if there wasn't data. So it doesn't look like we're getting any null values coming out of this joined part. So let's move along. Attribute value mapper is next. So we can now take a look at the crime value score here. So let's do a sort alphabetical ascending on the crime value. There's no nulls there. We can look at aggregator, crime value, sort alphabetical ascending. Also no nulls there. And finally, let's look at center point replacer. And we'll double check here for crime value. No nulls there. So it doesn't look like the nulls are coming out of the joined port or from any of these transformers, whatever operations they're doing. You can also get a similar result that would be a little faster by looking at the feature counts coming out of each port. So we've got about 68,000 features with a crime, and then that's reduced to a little under 10,000 after the aggregator, which is basically just putting them all in, the ones that share addresses into the same address. You'll also notice there are, let's see if we look at this one again, how many other features do we have in our caches here. So we've got joined, we've got 68,000. Unjoined left, we've got about 3,600 and about 14,000 coming out of unjoined right. So this is actually where we can start to identify where some of those nulls are coming from, because what's happening to these other two ports here? Unjoined right, we're just ignoring. Unjoined left, however, is continuing on and is also connected into the neighbor finder. So what we've done there, right, we're reading in the crime data, we're also reading in the addresses, and we're joining those because we're basically trying to get a score for the number of crimes that occurred at each address. So the joined ones we're keeping, these are going to be addresses that have had a crime at them. Unjoined left are going to be addresses that did not have a crime. And so we'd like to keep those because that's relevant for their crime value. Their crime value should essentially be 0 if they don't have a crime occurring there. But the problem is we're just taking these and not giving them a crime value at all because we're calculating that up here. And so these are passing through and going into the neighbor finder without any values for crime value. And so that's where that null is coming from. So let's go ahead and fix that problem here. And we can do that by giving them a crime value attribute because they're not getting it because they didn't go up through these transformers. So what we need to do is just give them one, and we can do that down here. So go ahead and find your feature connection line that's coming out of the unjoined left port of your feature joiner. It should have about 36, almost 3,700 features on it. And click that to select it. And then let's add an attribute creator. Can you just use quick add, type that in to add an attribute creator. Again, that's coming out of the unjoined left port of the feature joiner. And once you've added that, open it up, and we're just going to simply type in crime value. It's not going to appear on a list because it doesn't exist in these set of features yet. And then for the attribute value, we're just going to put in 0. Right, because these are addresses that didn't have any crimes occur at them. We still want to have them, give them a crime value. It'll be 0, there weren't any crimes. And so we can assign that here and click OK. Now we can go ahead and run our workspace back up to the expression evaluator. So find your expression evaluator at the end of your workspace on the right, and you can use run to this. And so now that we've assigned a crime value to those of 0 to those addresses, we should have a value of crime value for every address. And so therefore we shouldn't have any nulls. And so therefore our expression evaluator shouldn't issue any warnings. So I'll let that run for a moment. I'm just going to have a drink of water. So I'll switch over and take a look at my translation log. And this time only 10 warnings. Great. Looks like we have probably addressed the issue. We can confirm by looking in the visual preview. I'm going to open up my table view here, and I'll sort ascending again, alphabetical ascending again on crime value. And we'll see that the lowest value we have is 0. We don't have any nulls. So we successfully found and addressed that issue. So just to review, how did we do that? We added an expression evaluator to do something new in our workspace. That caused a series of warnings. We first wanted to figure out, okay, why do we have warnings now? So we looked in the log, and we saw there were null values in the expression evaluator. We confirmed that by inspecting its cache. So we confirmed the problem was that there were nulls coming in the expression evaluator, but it wasn't actually the evaluator that was wrong. The expression there was correct. And so we had to go back in the workspace to find out where that crime value was coming from. And it was generated up here in these 3 transformers. But we found that only a portion of our total features were going into those. The ones that didn't have any crimes were being missed. And so we just assigned a value of 0 to those with the attribute creator. And that meant that every address had a crime value. And so our expression evaluator worked properly. Someone was just asking, should all the crime values be 0 now? No, so you should only have a value of 0 for your crime value at addresses which didn't have any crimes, which would be those 3700 almost features that came out of your unjoined left port on the feature joiner. And so if you sort out alphabetical, or I guess you could sort numeric ascending, you should see 0. And then if you sort numeric descending, you should have some high values. So the highest I have here is 463. And right, those are the ones that are coming from this stream of features that did have crimes. If you have a value of 0 for all of your crime values, that means you put the attribute creator in the wrong spot. Make sure it's connected just to this unjoined left port. And then after that, it goes into the base of neighbor finder. Let us know in the questions panel if that didn't work out for you. For step number 6 here, we're going to change up the workspace a little bit. The sort of thing that will happen is you'll build a workspace and then the requirements will change. And in this case, the city has decided that actually they don't want to use parks for walkability because there's too many parks and so there's not enough variation. And instead they'd like to use swimming pools as the walkability score. And so we'd like to add and take into account swimming pool data in our workspace. But it's basically going to be the same workflow. We're just going to be calculating the distance to swimming pools. So we can reuse that area of our workspace, but we're going to use different data. So let's add a new reader with the following parameters. We're going to be reading OpenStreetMap XML data, which is .osm files. You can download these from OpenStreetMap in extracts. And we are looking for this one called Leisure, which has a series of layers, including swimming pools. So to add that, I'm just going to click on the blank canvas here and type in OSM. And then I'll use the arrow key to move down here on my quick add to OpenStreetMap OSM XML. So make sure you get the right one. There are a few OSM features here. So we want to select this one. And then we can browse, click the ellipses button here next to dataset to browse. We're going to go to C, FME data 2019, data, OpenStreetMap, leisure.osm. So that's what your dialog for add reader should look like, OpenStreetMap XML, and we're looking for the leisure.osm file. Once you have that, click OK. We'll get a select feature types prompt. There's quite a lot of layers here. I'm going to hit select all down here to deselect everything. And then I just want the leisure feature type. So again, click select all to deselect all of them and then just have leisure. So we only want to get one feature type out of this, which would be leisure. That's going to contain our swimming pool data. So once you have that, click OK, and that will add the leisure feature type for us. We want to, as I said, we're basically replacing the parks data with this one. So let's move this over to parks. I'm going to zoom out a little bit so I can find parks. I think it's down here. Yeah. And just as a bit of a preview, this is already crossing lines here. I don't like that, so I'm going to move this up here as well, just so that it's a little closer to the thing it's connected to. And I'll move leisure down there since we're replacing it. And so you should have something like this. So we've added that leisure feature type and we've moved it next to our parks feature type because that's what it's going to be replacing. So as I said, we're replacing these. So let's change the connection. We don't want parks to be connected up anymore. Instead, we're going to be using this leisure feature type. So you can hover over your feature connection line that's connecting parks and neighbor finder. And you can click and drag on the left part of that feature connection line to have it float and then connect it to the leisure feature type. And then finally, because we're no longer using this parks feature type, we can right click it and select disable. And so that will basically just save some performance. It won't read in that feature type when it's disabled. And since we're not using it, we can just do that. But we'll keep it in there because as we saw, the city has changed their requirements once, they might do it again. So we'll just keep it in there, but disable it. So this should be your setup now. You have the parked reader feature type disabled, and you have the leisure feature type added and connected to Neighbor Finder. Just had a question if I used auto layout to organize the workspace. I did not. Some people did choose to do that immediately just to make it a little easier to work with. I didn't do it yet because we are going to be styling this workspace in a later exercise to kind of clean it up a little bit. So I've just sort of been moving things around as I go to make it at least legible. But I didn't use auto layout. If you want, you could do that. Just keep in mind, it can change the layout pretty drastically. So your workspace won't look like the workspace in the manual or the one that I'm showing. So you'll have to kind of hunt around for your objects a little bit more. Okay, so let's start off here. We've added some new data. It's always a good idea to inspect that. And so go ahead and click on your leisure feature type and run just this. And that's just going to read in that layer and we'll check it out. We do actually get an unexpected input dialog here. That's fine. We can click OK to ignore that. And we'll see the data we have down here. I notice I don't have a background map on. I'm imagining everyone else probably does. Let's see if I can just turn that on here. There we go. So this is our leisure data. If you scroll through it, you'll notice that there are actually a lot of different kinds of facilities here. So if I scroll over, you'll see that we have things like different sports, and then the final one is leisure. And so we have a lot of things, including individual picnic tables, which is pretty impressive. But it varies what there is. There's gardens, playgrounds. So there's more than just swimming pools. As you might have guessed, there aren't that many public swimming pools in Vancouver. And so we need to filter this so that we're only using the swimming pools. So to do that, we'll use a classic tester transformer, the most used transformer. So to do that, go ahead and click on your feature connection line between leisure and the neighbor finder. So you have it selected, and then type in tester and add a tester there. What we're going to test for is we want leisure to equal swimming underscore pool. And that will filter out the data, so we're only using swimming pools. So open up your tester. Might need to expand it a bit to read everything. And for left value, you can click in that cell, click the drop down, and for attribute value, you can select leisure. You can also just type that in if you prefer. So for the value leisure, we want it to equal swimming pool. So you can just type that in. It's all lowercase. And there's a underscore instead of a space. So your dialog should look like this. In the tester, you want leisure equal to swimming underscore pool. Once you have your dialog like that, go ahead and click OK. So now we've replaced our parks distance with our pool distance. You'll notice, though, this is an important thing to do when you're making a change like this, is think about how did parks affect my workspace overall? Well, I did have some attributes, like attribute named park distance, which now is going to be actually calculating something else. So we're going to have to fix that attribute name. And we can find that in this attribute renamer up here. So this is after neighbor finder. So go ahead and find this attribute renamer and open that up. And you'll see what we're doing here is we're renaming the distance attribute, which we got from neighbor finder. We were originally calling it park distance, but you can go ahead and edit that now. And we're going to call it pool distance since we've changed the data. So go ahead and make that change in your attribute renamer. And once you've done that, click OK. You'll now notice that expression evaluator has turned red because it doesn't have that park distance value that it's looking for anymore. So to account for that, you can click expression evaluator And then we can change this here. You can just type that in manually if you want. Just change park distance to pool distance, and you'll see it will no longer be red since that's a recognized attribute. Once you've done that, click OK. Someone was mentioning that it would be handy to have a ability to read the different values here, which is true. In some places in FME, you can use an import function to import attribute values. It doesn't look like you can do it in the tester, though. I don't think you can. So that's an interesting suggestion to be able to read the values there and import them in. So we've made that change to expression evaluator. We now have pool distance instead of park distance. That looks good. So let's go ahead and run the workspace. You can just click run to this on the expression evaluator, or just by default, the run button will just use as many feature caches as it can and then run to the end. So we can also just click that. I should probably also save my workspace. I haven't done that yet. I'm just going to overwrite this one, I think, since well, no, that's probably a bad idea. Let's go, I'll let this finish running and then I'll do a file save as. Yeah, so I'm just going to save my workspace here. I'll do file save as. Again, you can save your own workspaces wherever you wish. I'll do day 5, exercise 1. Save that there. Okay, so we've run our updated workspace here. We have a new walkability score. And if you scroll over, you'll also see somewhere in here we have a pool distance score as well. There it is. It's actually right at the beginning. So instead of park distance, we have pool distance. Now, if you were paying attention earlier, you would have seen the distance for the parks, and now you're seeing the distance for the pools, and this looks pretty big. So if you look at our walkability score, that also looks really big. So that's actually changed, and it looks like something might be going wrong. So that would be, the only change we made was pool distance, so there's some kind of issue there. I see that Mark pointed out in a discussion with one of the participants today that about that having a drop-down list to search for values, for example, to search for swimming pool. There are some ways to do that in FME. He was suggesting maybe using an attribute filter if you want to check for those values, but also makes a point that FME tends to not assume that you can read in the data and know the values before translation is run. It'll import the schema so it knows what the attribute names are and their types, and it keeps track of that, but it doesn't necessarily read in the data to know what data it's working with until the translation is run. So that's just an important kind of consideration to keep in mind. Okay, so it looks like pool distance is the source of a problem here. We're getting really big values for that. This is an example. If you look in the log, we don't have any errors. We have the same number of warnings. So that actually doesn't help us in this case. Additionally, the feature count numbers look correct. We're getting the same number we had before, so there's something else going on. Let's try inspecting the leisure data and the neighbor finder data together. So click your leisure data once, and then you can control or shift click the neighbor finder to select both of them, and that will add both of them now to our visual preview. Now, for now, it looks like everything's good. They're both showing on the same background map, but this is an important thing to remember, is that when your background map is on, if FME knows the projection of the underlying data, it will just reproject it to spherical Mercator so it can show it all on the same map. That doesn't necessarily mean that the data is in the same projection. And you can find that out. One way you can do that is just by turning your background map off. So let's right click. You can right click the graphics view, go to background map, and select background map off. And now this will just show the data however it can. And you see there's something weird going on here. If I believe this would be zoomed to full extent. Yeah, so if you zoom to full extent, you see that these aren't aligned at all, which implies that they're probably in different coordinate systems. And we can confirm that by, let's see, I'll turn my table off and I'll turn on my feature information window, and we'll select one item from this layer. Let's see if I can do it from here. So for neighbor finder, we're in UTM 83 zone 10. And then if I select the leisure layer, that's in lat long 84. So there's the issue. We have data in UTM. So the original data, the addresses, et cetera, that's in UTM. This new leisure data is actually in lat long. And so when we're doing the neighbor finder, it's calculating the distance. It's just very high because they're not in the proper projections. They're not in matching projections. So because we've identified that the issue is a coordinate system mismatch, we need to reproject our data. And so to do that, we can reproject our leisure layer and we'll put it into UTM so it matches. And we can do that in a few ways. In this case, we're going to use the reprojector transformer. So go ahead and add one of those into your workspace by typing on the canvas reprojector. And then I'm going to have to move some things around to fit that in. So I'm just going to move these three transformers back a little bit and then put reprojector in. So I've just added a reprojector between the tester and the neighbor finder. I'm going to open up its parameters. And I could just read the coordinate system from the feature, but I know that it's in LL84, so I might as well type that in for the source coordinate system. And then for the destination coordinate system, we know we want to get this into UTM 83-10. That's the UTM zone for Vancouver. And so now we are going to be reprojecting our data, and it should hopefully match up. So once your reprojector dialog looks like that, click OK. And I'll save and run the workspace again. And now hopefully that pool distance will just be a lot smaller because the data actually overlaps. Oh, I just got a warning. Did I type something in wrong? I think that's correct. Yeah, that should be okay. Let's see what happened. Open up my table view here. That's more like it. Yeah, pool distances of 0 to 1,000 meters instead of whatever it was, 5 million or something. And so there we see we have a much more reasonable walkability score now. Okay, so hopefully everyone got to that step. Sorry about the initial data snafus for some of you. Hopefully everyone has the correct workspaces now. Basically what we did in this workspace, we added this expression evaluator to calculate walkability, and then along the way we ran into a bunch of issues, and I showed you some steps you can take to identify and fix problems, to debug. The sort of key steps we used were look at the source data, look at the log, trace back the transformation using feature caching through the different transformers until you identify the source of the problem, and then you can address it. Murphy's Law number 31 is, if it's stupid and it works, it ain't stupid. That being said, sometimes you will find yourself with a workspace that could look a little better, which would improve its maintainability and its performance. So let's look at some advice for setting up your workspace with maintenance and performance in mind. Sometimes workspaces are authored in a way which makes them hard to maintain. There's some indicators you can look out for that would show this. You could think of them as design patterns. And so some inoptimal design patterns would be duplicated transformers. So if you have a large number of transformers of the same type, they can be difficult to update or to scale. We'll also talk about performance. So this is basically just the idea of getting your translations to be carried out using the smallest number of resources. So let's look in some detail first at maintenance. How to set up a workspace that's easy to maintain. So obviously, you don't want to duplicate transformers. Here's an example where we're filtering out our features by their value of year. So each feature has a year attribute, and then we're using an attribute filter to send it in different directions based on its values. And then we're using multiple attribute managers to do something to each stream of features. Obviously, there's some problems here. There could just be an efficiency problem where maybe the attribute manager could come before the attribute filter. Do we actually need to do something different to each year? If we do need to do something different to each year, you could do that using, for example, conditional values in the attribute manager instead, or you could use an attribute value mapper or a schema mapper. And so basically the rule of thumb here is if you can do it with just one transformer instead of many, is usually a good idea to do it with one. I do know some people, and this is a good example of how best practice differs, people have different opinions on this for FME. So on our team, for example, Ryan, he really likes to build workspaces where it's very clear just from looking at the name of the transformer what's happening. So rather than using one attribute manager to do a ton of attribute operations, he might want to use an attribute creator and then an attribute renamer and something expression evaluator, something like that. So it's a bit clearer in each transformer what's happening. And that's a pretty valid way of doing things, really. It's clearer from a style point of view, but from an efficiency point of view, you might choose to just use one transformer to do everything that you need. Another problem with maintainability is complexity. Just because a workspace is complex doesn't mean it's good. So a key example there would be duplicating FME transformer functionality by using scripting transformers like the Python caller or the Tcl caller or the R caller. And that can, maybe it saves you some time if you already know those programming languages. But in many cases, whatever you're doing there could be done in FME. And if you were to do it in FME, that makes your main workspace maintainable by future FME users who might not know those languages. And those languages might also require or depend on external libraries, which you'd have to worry about. Whereas if you just do it in FME, you know that FME will be backwards compatible and continue working. So there's definitely it can be tempting, especially for new users, if you already know Python, to just do a lot of stuff in the Python caller. But there are legitimate reasons to reduce the complexity of your workspace and the barrier to entry to editing and maintaining your workspace by using transformers instead. There's also some differences of opinion in how much you should break up your workspaces. I would say nowadays, if you're still working primarily just in a desktop environment, so maybe you're the only really major user of FME and you're just authoring workflows and running them in FME desktop, then it's probably a good idea to use pretty big workspaces. It doesn't really make sense to break them up and use workspace runners or something like that most of the time if you're just working in a desktop environment. Now, you would probably hear from our server team if you were working a lot with FME server, and particularly with our new feature of automations in 2019. In that case, it's often a good idea to split up your workspaces into smaller units, and then you can control when they run using server. So that does sort of depend on your use case, but it's easier to see what's happening as a whole if you have everything in one workspace. So that's good to keep in mind. And a final piece of best practice for maintainability would be connections. We'll talk about database connections here. This could really apply also to other kinds of connections like web connections to particular services. But it's a good idea to try to make these maintainable by using shared naming conventions and sharing these connections between users so that someone can run, different people can run the same workspace on their machines, assuming they have this correct database connection set up. You can embed database connections in a workspace, but that isn't very secure. It's actually just saved directly in the workspace and anyone could open it up and see the connections. Whereas using a database connection will save it to the user's profile, so it's a little bit more secure. You can pretty easily add a database connection. For example, if you're adding a reader for PostGIS, you could just click Add Database Connection. You just fill in the credentials, and then that'll be available for you anywhere you can connect to PostGIS in the in Workbench. So those are some tips for maintenance. In terms of performance, there's a few different ways you can improve the performance of your workspace. That would include both CPU and memory requirements. The first one would be filtering input. So this is, I think, one of the biggest is don't read in more data than you need. A good way to do that would be use a where clause. Most database readers have an optional where statement in the feature type. For example, I think our addresses should have one. Yeah, so you can see that here. If you open up a feature type for a database, there's a where clause. And so here you can construct a where clause using your different tables and only read out those features, and that will be faster than reading everything. Another source of slowdown in your workspaces would be excess feature types. So in this case, we've got in the manual here, we're only using 3 of these 8 feature types that we're reading in. But just because they're on the canvas and they're not disabled, those will still be read in when you run your workspace, and they will slow it down. So it's a good idea to get rid of those if you're not using them. You can see that we have that problem in this workspace we were working on earlier. We have postcode boundaries just sitting here, not being used. Another big point here would be excess attributes and lists. And you can also see we have that problem in this workspace. You might see where this is going here. You know, if I open up expand the list of attributes on our final transformer here, we've got quite a long list there. And you know, if we're only trying to get that walkability score, we don't need all of those attributes. We're really only using 3 of them in the expression evaluator. So that is another way to reduce the time it takes to run your workspace, and also the size of your workspace or your template would be to remove excess attributes. A really big cause of these would be the merge attributes checkbox and the generate list checkboxes on a number of transformers. These allow you to retain attributes when you're merging streams or joining data or overlaying it, but you should really only be doing that if you need it. And additionally, if you choose to do it, there's often a choice of all attributes or selected attributes. So you should make sure you're just doing selected for the ones that you actually need, so you don't end up with a huge amount of attributes that you're not using. Lists are particularly bad. We don't talk about them a ton in the desktop basic course, but it's essentially you're able to store an attribute that has a list of values. And so those can get very long and very weighty pretty quickly. Another way to improve your performance is to use error trapping. This is just kind of good programming best practice, but it applies to FME as well, which is basically trying to set up your workspace so if there are problems, you'll identify them sooner rather than later. So an example here would be if you're planning on using a value, if you need the value of zone name, then one of the first things you should do with your input data is put it in a tester and check for each feature that zone name has a value. And then maybe you'll just remove any features that don't have a value for that, something like that. So let's work through exercise 2. We'll continue to work with that exercise we were just working with, the workspace we were just working with, and apply some of these maintenance and performance methodology skills to our workspace here. So if for whatever reason you weren't able to get to this final result with pool distance, etc., for exercise 1, then I would recommend opening up the exercise 2 begin starting workspace. The path is in the table at the top of exercise 2 there. I'm just looking at the chat window because I'm about to paste in this URL, and I see Mark made a good point, so I will just vocalize that as well, which is the performance issue and maintenance issue is not so much using multiple transformers. That's fine. They're kind of two separate issues. I think he's correct there, but you don't want to use multiple of the same transformer, especially if you can do it using one. So if you're unnecessarily streaming your features, that can be a big issue for maintenance and for performance as well. So I'm going to paste in the link to exercise 2 here. And so here we've got basically just continuing with the same workspace we had earlier. And what we're going to do is extend the project a bit to see if each address falls inside noise control. And so the first step will be to clean up our output a little bit. Again, if we look at the output list of attributes here, we have a huge number. You can see that some of those pesky lists I was mentioning. We have a crime list that looks quite long. We also have a lot of data from, I think this is from the neighbor finder, that's quite extensive. So it's a lot of stuff we don't really need. Probably all we really need would be maybe the address, the component parts of walkability, and then the walkability score itself. So let's try to get rid of some of those excess attributes first. First thing we'll do is to save our workspace as a template. And this is going to let us compare basically how much we've reduced the size of our workspace and the size of attributes, because the template will save both the workspace, the definition of the workflow, and also the data. And so that will give us a good sense, the caches, I should say. And so that'll give us a good sense of how much we're cutting down the size of our workspace. So to do that, go to File, Save as Template. Make sure you have everything cached. If you don't have feature caches, you should run your workspace first, because we want to save this with the caches. And so go File, Save as Template. And then you can call this whatever you like. I'm going to call it Day 2, Exercise 2, Begin, because we'll save a template at the end to compare. And I'm going to also make sure I check this box here, Include Feature Caches. So call it whatever you like, and then we're also going to check Include Feature Caches. And this is a good thing to know about generally if you're sharing workspaces with other users. You can save a workspace with feature caches and share it with them. They'll instantly be able to start working on it because those caches will already be there. So once you have your save template dialog like that, click OK. And then what we'll do is we'll just quickly check the starting size of our template. So I'm going to go to C, FME data 2019, workspaces. This is where I saved mine. And so I've got my template file here, and it's just under 50 megabytes. So my workspace with all the feature caches is just under 50 megabytes. So in this exercise, we're going to try to get that down by reducing the amount of attributes. So again, it's not really a big deal to have a large template file. You might need it to be big, but in this case, we know it doesn't have to be that large, and that could be affecting the workspace's performance. As I said, major issue here would be the number of attributes and lists. So let's get rid of those. One of the ways to do that would be with an attribute keeper. And so I'm going to move my expression evaluator over to the right to make some room. And then in between, I'm going to add an attribute keeper. And this is, we have attribute remover, we also have attribute keeper, and these are basically transformers you can use to quickly change what attributes you're working with. So once I've added that, I'll open it up. And you see you have a choice of attributes and lists to keep. So for attributes to keep, I'm going to click the ellipses button. And we only want crime value, noise zone score, and pull distance. So you see, by only keeping those three, we're removing quite a lot of attributes. What this also tells us is that we could actually probably remove these earlier, because we're doing this at the end of the workspace, which is fine. The written data will be cleaner and smaller, but we could probably also remove these earlier. So then we'd also would improve the performance of our workspace because we wouldn't be keeping these the entire time. So once you've added those three, click OK. and then you can click OK again. Well, actually, yeah, I guess we should, yeah, you can click OK again. We'll do it this way. So now we've removed those 3 attributes. If you look at, or we kept only those attributes. So if you look on your expression evaluator now, you will just have the 3 that we kept and then the one we calculated in the expression evaluator, which is walkability. Now, we still have that crime list attribute that's floating around our workspace, and it's being used in every transformer. So that's really just slowing down our workspace, keeping that around, and it would be in all these caches as well for when we save the template. So let's try to remove that. We don't need it. We don't use it in any part of the translation. It's just on our features for some reason. So one thing you can do if you found something like a pesky attribute and you want to get rid of it, but you don't know where it is, especially if you're in a larger workspace, you can hit Control F to search your workspace. You can also click it in the navigator if you prefer. And then let's just search for crime list. I don't believe you want to put in the brackets, and click OK. And then your results will show up in the navigator window, and you can see that it has returned the aggregator as being the source of crime list. So if you click that, it'll zoom over to there and select it for you in your workspace. You can open that up by double clicking it, and let's see where we are generating this. It looks like we do have a generate list section down at the bottom, and that's where crime list is coming from. We've decided we don't actually need that, so click the checkbox to uncheck generate list. And then click OK. You'll notice that does cause all of these caches to become stale because now they don't reflect what is up to date with the workspace, but we'll be rerunning it in a moment anyway to solve that. Another reason the workspace is a bit slow is because we have those extra feature types we're not using. And so we have, for example, postcode boundaries. So let's get rid of that. That's all the way over here on the left. These 2 postal feature types come from the same geodatabase, and the original author just read in everything and they didn't actually need it. So click your postcode boundaries feature type and then click delete to remove it. And now we won't be reading that unnecessarily. And we do have this parks feature type is disabled, but we should also probably just remove that. We're not using it, so you can click delete to remove that. It will prompt you because this is the only feature type for that reader. If we want to remove the reader as well. And sure, yeah, we're not using it, so let's click yes. So that's excess feature types removed. We've got that list out of there, so we're definitely making good progress simplifying our workspace here. There's another thing we can do here as well, which is to reduce the number of caches we're saving in the template. And this is where you get a little bit of control over, like I said, it's nice to share templates with your colleagues because you can, send them a workspace and already has the caches they can get running immediately. But sometimes you don't want to send them every cache because it can be a bit much. You don't need every single one. And so one thing you can do to get around that problem is to use collapsed bookmarks. And we'll talk a little bit more about bookmarks in the next section. But what you can do is when a transformer is on the canvas and you can see it, it will get a feature cache. But if you put it inside a collapsed bookmark like this, it'll only cache the last, basically the output port of that collapsed bookmark, and everything else in there won't get cached. So what that means is there's these 5 transformers towards the beginning, which is where we're basically just doing a bit of editing on our addresses to prepare to join them to the crime data. We don't really need to see that step by step. We're probably only interested in, did we prepare them correctly? So we'll have 1 output port there, and then the rest of these won't be cached. So a way to do that is let's go ahead and find those 5 transformers. They are over here. They're a bit messy. You could clean them up here and reorder them if you want, but I think for now, let's just hide them in a collapsed bookmark. We can fix those in the 3rd exercise when we look at style. So to add these to a bookmark, you can just click and drag a rectangle around all 5. Make sure they all have that little blue halo so they're selected, and then let go. And so that'll have us select all 5 of these. And then you can press Control B, and that will add a bookmark. We'll talk more about those again, but you'll probably have seen them already this week. These are basically ways of organizing sections of your workspace. Then you should give it a logical name. So I'm going to call it prepare addresses to join. And then I'm going to hit this down button here, downward pointing arrow, and that will collapse the bookmark. And so now it's smaller, it's tidier, and when we run our workspace, we're only going to be saving a single feature cache. So I'm going to save this, and let's rerun it now. So now we're going to rerun it. It's going to update all those caches for us. We're going to be removing the lists, removing the attributes we don't need at the end, and also only caching one, only creating one cache for these 5 transformers towards the beginning. So that looks pretty good. Let's go ahead and do File, Save as Template. And then we will, you can name this whatever you like. I'm going to call it Day 5 Exercise 2 Complete, because this is the end of the exercise after we've removed several things. Don't forget to include your feature caches again. And then we will save that as a template. And if I go to my folder here, now I can compare the beginning and ending sizes here. So before I cleaned up my workspace and the attributes, etc., it was about 50 megabytes. Now, after cleaning up, it's about 16, almost 17 megabytes. So we cut that down quite a bit by removing some of those. So you can see this has advantages in terms of complexity. It's a little easier to maintain now. It's a little clearer. You don't have all those extra attributes you're not using. It'll run faster because you don't have all the extra attributes. And if you wanted to share it with a colleague, even with the caches, it's not that big now. You could send that over email. Okay, so that's exercise 2. We removed unnecessary attributes. We tracked down unnecessary lists and removed them, improved performance by collapsing a bookmark, and we saved a workspace as a template, including caches. Someone asked if disabling and removing a reader have the same effect to improve efficiency. And I think I would agree with Mark. I think disabling would be maybe just a little slower than completely removing it, because it does still exist, but they are functionally pretty similar. So if if you have something in your workspace and you're like, oh, I might need to come back to this and use this later, I think that's fair to just disable it. But if you're sure you don't need it ever again, it's a good practice to just get rid of it and delete it. Okay, let's move on to the last section here. This is style. We're going to talk about how to make your workspaces look functional and easy to use. And as I said earlier, this really stems for the fact that you want to be friendly to both other people and also future you. Do yourself a favor by making your workspaces easy to look at and understand what's going on. So if you have to open them up in a few years, you'll know what they mean. So in this section, we'll basically be presenting an FME workspace style guide. We recommend that you have consistent naming conventions for everything you're doing in Workbench. So whether if you do rename transformers, to use a consistent naming convention there. If you are titling your bookmarks, how you're saving the names of your workspaces, that's all important to establish consistency. Here's an example of poor design. Just a screenshot from the manual here, although you can also see it's basically the same of what we're looking at over in our exercise. Take a second, think about why do you think this is designed poorly? What would be a problem here? What makes it hard to figure out what's going on? Here's some of the things that occur to me. For one, it's pretty cluttered. Everything's quite close together. There are no comments indicating what any of these are actually doing. So of course, transformer names are a good guide. This is replacing something, a string. This is changing the case of something. This is aggregating something, but you don't really know what's going on. So comments help you describe, annotation really is what we call it, help you describe what a specific piece of the workspace is doing. Bookmarks would help join these together so we know what the different sections of the workspace are. Another problem with the clutter is that there's a lot of crossed connection lines. And while you can, with your eye or your mouse, you can trace the path and figure out what's happening, that extra second of having to figure out what's going on adds up. And so when you have all these cross lines like you do here, it just becomes hard to look at and hard to quickly figure out what's going on. And as a little an exercise in thinking why you should do best practices, imagine someone handed you this workspace and we're told, and they tell you, oh, yeah, this is from our old colleague. It stopped working this morning. Could you fix it, please? And you would probably start tearing your hair out because first, before you can even fix it, you have to fix the design so you can actually figure out what's going on. Whereas if they had used a good style guide, it would be easy to tell just at a glance what's going on. You can think of this akin to, if you do any programming, this is akin to commenting your code. You don't want to hand someone lines and lines of code with no comments. It's going to be a lot harder to untangle what they're doing than if they had nicely commented lines and sections and functions where everything was clear. So you want to think about that the same way with workspaces. In my opinion, the most important thing you can do to improve the clarity of your workspace is to use annotation, which you might hear some people call comments. And there are two kinds of annotation: summary annotation and user annotation. User annotation is kind of nice. It's the one I use the most because it lets you just type in whatever you want. You can add it to a specific object, connect it to a feature type or a transformer, and it'll have a little call out bubble. Or you can just place it free floating as kind of labeling an area or doing a comment. Or some people actually use these free floating annotations to do basically documentation or update records or something like that for their workspace. And you can use this annotation to explain what's the logic behind why you use this transformer. What is it actually doing? You can also use, I guess I should say how you can add that. You can click on an object. So for example, click on this crime feature type here, and then I can hit Control K to attach user annotation. So I could say read in crime data, something like that. That's not super specific, but it's good enough. If you just are in a blank part of the canvas with nothing selected and you add annotation, it'll be free floating. So maybe you're going to label sort of a section of your workspace. You could do this with a bookmark as well. You could do that, or you could say something like last modified by, and I could put in Sam Walker 5319 or whatever. So you could start to keep kind of records like that if you want within the workspace. You can also add annotation by right-clicking objects and attaching annotation. And finally, you can modify the styling of the text in the annotation by selecting it and then using these tools up here. So you can bold, increase or decrease the font size. You can put in links, which is quite a handy feature. Change the color. Summary annotation is a slightly different way of annotating your objects where FME actually generates a comment automatically. And you can attach this to basically any feature type or transformer. And this is usually colored to distinguish it. So if I right click and I said show summary annotation, which is also Control-Shift-K, that will add in this blue annotation box. And as you can see, this basically just spits out all of the relevant details, the parameters for that object. So for some objects, like this reader feature type, it'll be quite large, right? This is telling me a bit more about the format, allow geometries. It's giving me the list of exposed attributes and their type in a little table. And the really nice thing is that this will automatically update in response to changes. So if the underlying GDB changed and maybe they changed the schema, they removed one of these attributes, that would get removed from this table, which is a really nice feature. The only thing to keep in mind is you can actually convert this to attached annotation and then edit it, but after you convert it, it's not going to automatically update. So the little tip here at the bottom, this is kind of how we suggest you use these two different things, which would be show summary annotation to show what actions are taking place, and use user annotation to clarify why an action is being carried out. So the ones you add yourself, you're sort of explaining why this is happening, whereas summary is good for just showing what is going on. And so you can use that if there's a particularly important transformer or one maybe that does have more complex parameters and you want to show how you've set it up, you could add the summary annotation and then maybe add a user annotation saying, why is this important or whatever. So the other major tool in your toolbox for style and documentation of a workspace is bookmarks. Annotation is only ever attached to a single object or it's just free floating, but you can use a bookmark to group multiple objects or organize sections of your workspace. And the interesting thing about bookmarks is they're not only for documentation and sort of making it easy for people to figure out what's going on, they have functional purposes as well. So there's several reasons you could use bookmarks. You can use it for design to subdivide your workspace, which helps other people. It can also help you when you're developing your workspace. You can think, I have to add this piece, then this piece, etc. So you can actually lay out bookmarks before you even build your workspace. I do that a lot to plan it out. Access is another reason you could use bookmarks. This allows you to quickly get to a certain section of your workspace so you can navigate around using bookmarks. You can move big chunks of the workspace using bookmarks. That would be editing. So if you want to move the order of things or move the location on the canvas, you can move your bookmarks like that, and that will move everything within it. And performance, as we showed earlier, you can improve your performance when using cache data by collapsing your bookmarks. Bookmarks are pretty straightforward to use, so I'll uncollapse this one just to show you. Once you have objects in it, you can click and drag on the top section here, the name, and that will move everything within it around. You can resize them just by hovering over the edges, getting a resize cursor. You can click the cogwheel to get options, so you can change the name there, change the color. There's a custom color support as well, in addition to swatches. You can also, this is slightly interesting. I almost always just have this mode on move with bookmarks, so you move the things with it. But sometimes people want the bookmarks to actually move independently of the object, so you can do that as well. You can set a set of palettes. If you go to Tools, FME Options, Appearance, you've got a whole set of different swatches you can use here for your palette, and so that's nice if you want to customize that. And right-clicking a bookmark does give you some other sort of shortcuts, things like selecting all the objects, disabling all of them, etc. So let's talk about some different reasons to use bookmarks in a bit more detail. So bookmarks for design, these are great for just sectioning your workspace. You can color code them if you want. And the names of bookmarks will appear in the navigator window. So over here, you can see I've got my bookmarks section. I can expand, there's prepare addresses to join. I can expand that and it actually lists all the transformers within it as well. So you get a nice outline view of your workspace. Here's a good example of, if you have a huge workspace, and this, this is big, but we get some from customers, and I'm sure some of you work on ones that are even way bigger than this. It's really necessary to use bookmarks at that point, or you're going to be lost if you don't have some sort of organization. We've heard this before, and now I use this a lot, saying that bookmarks are like paragraphs for your workspace, right? Once you've done with a major section, you can put in a bookmark. You can also see from this example, you're allowed to nest bookmarks. And so that lets you, have several levels, and that will show up in the navigator as well. We've been over collapsing a little bit in the previous section, but again, that basically just lets you collapse this down to the size of a single transformer, and it will hide it. And you can expand it if you need to open it up and see what's in there. Will save your time on caching, and just visually will make your workspace a little more simple. And so you can see an example. This is the same workspace that's actually shown up here. So you can take this giant monster of a workspace and collapse everything and turn it into this. And so there, basically, you're seeing that your your bookmarks are basically becoming little transformers. So you have one transformer that does the analysis, workspace analysis, one that does the style analysis, etc. You also see when you're collapsing and uncollapsing bookmarks, they actually will move objects around your workspace. So here I have my feature type quite close to the collapsed bookmark. So when I expand it, it does actually move it down. But then when I collapse it, it'll move it back up. So it's kind of a nice feature. It's a good way to quickly hide and view things in your workspace without totally messing up your layout. And finally, you can rename these ports here. So that makes it almost even more like a single transformer. So instead of calling it that, I might say that the input port is actually called addresses, and then the output port is called cleaned addresses, or something like that. See, that doesn't actually change any of the underlying transformer parameters, but it will remember that that's how I set up my bookmark. Another reason you might use bookmarks is for quick access, and this is how you can quickly kind of move around your workspace. So let's say I was over here working on something at the end of my workspace, and then I remembered, I have to change something in my bookmark. I could find it in the navigator and click it and zoom back over there. And so in this case, it's not that complicated. It's not that big of a workspace. There's only one bookmark. But thinking about that one we just saw, that huge one, this would let you really quickly zoom into the section you want to see without having to manually pan and zoom around your canvas. There's also a feature called the bookmark navigator. Let me add one more bookmark just for an example. Don't have to do this yet. We will be doing something similar in the next exercise, but I've added a bookmark called calculate crime value. And so you'll see that in my my bookmarks list here. And then what you can do is actually navigate between those using a special feature of the bookmark navigator. By default, it doesn't show up in your toolbar. You can add it by right-clicking and going to Customize Toolbar, and then finding it on here. Let's see if I can find it. So it looks like this. It says Show Bookmark Navigator. I'm just going to pop that in after the Add Bookmark button on my toolbar. You can just click and drag to add or remove things from your toolbar. And when that's added, now you see I have that here. And what this does, it gives me a drop down with my bookmarks. And when I click them, it'll zoom to them. And then when you want to go to the next one, you can hit next, and it will go over and zoom to it. And so this is nice for quickly moving around your workspace, but it also, people use this really effectively to present workspaces. So if you ever make one and you have to explain to someone how it works, you can put all your bookmarks in order and then use the bookmark navigator to zoom around, sort of like a Prezi presentation, and show them all the different sections without having to think about it and doing it manually. That can be really useful. You should also note that by default, bookmarks are sorted alphabetically. So if you want to change the order they appear in the bookmark navigator, you can undo that, and then you can manually order them. So I would probably want mine ordered like this, since prepare addresses to join is first, and then calculate crime value would be next. Of course, bookmarks are also very handy for keeping your workspace organized and editing it. They allow you to move large blocks of transformers and feature types around quickly and easily. And finally, as we saw in the last workspace, you can use bookmarks for performance. And so when feature caching is turned on, features are cached at every transformer. So for larger workspaces, obviously, as we saw, this could take a lot of time and resources. But for collapsed bookmarks, only the output transformer port is cached, and that can just save you a lot of time and resources. So that was bookmarks for style. There's some other aspects of style we'd like to talk about as well before we do the exercise. One of those would be object layout. So of course, how you lay out objects on the canvas is ultimately personal preference, but you do want to make sure that the flow of the workspace is obvious at a glance. So here are some ways you can do that. Layout methods vary. People do this all sorts of different ways. So 3 of the common ones would be aligning your objects so all of the connection lines are straight, like this. I prefer to line up the top of all of my objects. And so the connections will be a little like S-curve, but then the top of all the objects will be aligned. And then sometimes if you want to save space, you know, if you're trying to have a nice compact workspace, you can move left to right, but then also align objects vertically. It takes up a little bit less space on the canvas and can be easier to view your whole workspace at once. And so again, with best practice, this will vary. You can do this however you want, but the real thing is to be consistent. So have your own style and follow that, because that will make it easier for other people to see what you're doing. It's definitely not a good idea to switch between these 3 different styles a lot during the workspace. You can throw this one in every now and then, and it's still pretty obvious, but it's a good idea to pick one and try to stick to it. If you want some help laying out the objects in your workspace, you can use grids and guides. These are on by default, guides are on by default. And so you can see that, if I grab a transformer, let me zoom in a little bit, grab a transformer and start moving it around, you'll see these little horizontal lines showing up that are, and then the mouse gets a little sticky, showing that it's snapping to the guides to keep in this case, to keep the top of these transformers aligned. You can also go to the view menu, grids and guides, to get some options. So you can change the guide color, how sensitive it is, and its gravity, so how quickly it will activate based on how close you are. You could also use a grid, and this will snap to a grid instead, so you can change the size of it and the gravity as well. So if I did something like this, then I could lay things out like this in a grid. And that's nice because that allows you to control the distance between objects. You could say, okay, every transformer has to be 2 squares apart, and then you'll have a nice evenly layout workspace without having to manually align stuff. There is also the auto layout tool, which some people were mentioning earlier that they used. Why don't I do a little test and we'll use that now and see what we think of the result. I'm gonna turn my guides back on, turn off the grid, and then I'll zoom out. So it's not very legible, but here's my whole workspace. If I auto lay it out, let's see what changes it makes. Okay, so you can see auto layout does often take a very horizontal style. It doesn't line up all of your feature types. It rather lines them up when they're used. It does allow for crossed lines, which is something I don't love, but it turns out it's is a little tricky to set up for it to automatically do that. And then it basically just moves left to right one by one. And so it's fine. I mean, it's a good starting point. I would say if you have a really messy workspace, it's not a bad idea to just run that and then start moving things around, because it will definitely be an improvement. But it doesn't compare to really taking the time to lay things out yourself. There are also different connection styles. You can have straight lines, curved lines, or the Manhattan distance lines. And you can shift between those from the view menu. So view, connection style. I should zoom back in so we can actually see them. So right now I've got the curved connection line on. You can instead do squared. And so this will basically do a Manhattan distance, go halfway and then turn and then go the rest of the way. Or you can do the straight lines, which just come out a tiny bit and then do a straight diagonal line. This is definitely personal preference. We have people here at SAFE that use all 3. I'm a curved kind of guy, I guess. Those are the ones I like, but you can do whatever you like. The one thing that I would point out, I think there's a tip on this in the manual. Yeah, so the one thing to watch out for if you use squared connections is that they can lead to some obfuscation in this case, where the area where they turn lines up, and then it's actually not clear at all what's connected to what here. It's a slight edge case, but you do see it happen sometimes. And that gets into the general idea of avoiding overlapping connections, which I mentioned. Basically, just try not to overlap at all. It's the best way is to just avoid it if you can. There are some cases where it's quite hard to avoid and you have to remove whole parts of your workspace around, but I found that's usually worth it because it helps improve the clarity of how how features are flowing through your workspace. One way you can avoid those connection lines and keep things tidy, you can think of this almost like a cable tie if you're into cable management when you're setting up your PC or whatever, is using junctions. And these allow you to just put in what's kind of like an empty transformer. It's just an input and an output section, and you can connect things to it. So that allows you to take, in this case, many feature types and put them all into one junction before putting it into a transformer. So it's basically just a little node you can use to organize and connect up parts of your workspace. And you can add those with quick add, just type in junction. So it looks like this, a little guy like that, and you can just connect objects up by clicking and dragging. So again, those are basically just used for making a lot of many feature connection lines going into one. A slightly more advanced form of style, which is useful, I would say, primarily when you have a big workspace, but it can also come into play when, if you want to keep all your reader feature types lined up, for example, and you only do a little thing to one of them and then you don't need it again until way later in the workspace, you can use hidden connections and tunnels. And so what this lets you do is basically make a little wormhole, little tunnel that will allow features to travel across your workspace without them being visible. So let's see if there's a good example. I mean, this workspace is still a bit of a mess, but let's say this one is kind of long. Maybe we didn't want to show this going across our workspace. So what you could do is you could right click and select hide. And so you see now we have these little kind of radio or little transmitter symbols on the end of the ports, and the connection is hidden. And you can see it again if you click an object that's connected to it. It'll show it in this this dotted grayed out line, so you can still see where it is when it's relevant, but the rest of the time it doesn't clutter up your canvas. So that's one way to do it, is to basically hide your objects. You can unhide by right-clicking an object it's connected to and clicking Show Connection, and that will bring it back. You can also create a tunnel. It's another way of doing it. So if you find a connection and you want a tunnel, you can click Create Tunnel, and that does this. And what that does is it sort of just saves you some time. It puts in a junction, which it annotates with the name of the output port, and then it hides the connection between the junctions. So this is, you can do this manually, but it's just a little faster way of doing it. And this can just be a little better because you automatically get that annotation, and it just makes it a bit more obvious maybe that there's a connection here that's being hidden by showing those little tunnels. And again, same process applies. If you right click and click Show Connection, it'll come back. So that's some tips and tricks for the FME style guide. Why don't we do exercise 3 here? We'll clean up a workspace to get it into good shape so someone else would be able to understand it. I'm going ahead and actually open up the starting workspace for this one, I think, because I've messed around with this one too much now. So I'm going to open up exercise 3, begin. You can continue from the one you're working on if you want. That would probably be fine. But I'll just, because this one is going to get a little bit more subjective. But I'm going to go ahead and open up best practice exercise 3, begin FMW, not FMWT. And then if you want to follow along, you could open up this, or as I said, you could just do the same with whatever stage you're at in your workspace. So the idea here is, this isn't very well laid out. We're just going to try to improve how this is laid out and to also document it. So first, let's clean up some of these transformers, and we're going to move them around so there's no overlapping connections. So the first thing to do is there's a couple areas where we have this scenario where we have two ports and they're basically coming in from the wrong direction. And so there's two ways you can fix that. Of course, you can move the actual objects so they're on the right side of one another. So I could move this collapsed bookmark up here, and now they're not crossing. Or another option is you can actually move the order of ports. So I could right-click my left port and say move down. And now I have that set up like that, which is great. I think that works. It can be it can throw people off a little bit sometimes if they're not paying attention and they look at your workspace now. They might assume, because it normally is at the top, that that would be left when they're in the parameters and things, but it's definitely a valid option. So I've done that, and now let's go ahead and do that for all the workspace. And you might get your workspace into something that looks like this, right? Where we've got a couple sections with bookmarks and we've got no overlapping connections. So you can follow along if you want. I'm going to make this window a little bit bigger here. I'm going to go ahead and start doing this for my workspace. So I'm going to line things up. I like to try to keep all of my readers at reader feature types at the beginning if I can. And so I'm going to move those over there. I think those are all of them. And so since those are all my reader feature types, I'm going to select them and insert a bookmark. And I'm going to call that reader feature types. You'll see this bookmark gets automatically generated when you generate a workspace. So I like to keep that pattern. I'm going to click the cog wheel and select. There's actually a special color for readers and writers, which I tend to like to use. And so I'll add that. I should probably describe what I'm reading in. So for crime, I'm going to hit that and press Control K and say read in CSV of crime. You'll see in 2019, we now automatically color annotation within a bookmark to match it, which kind of just helps solidify color coding. So I'm going to read in a GODB of addresses. I'll label my postal address layer, and then for leisure, read in an OSM XML of swimming pools. So something like that. This is the kind of thing that we're doing in this exercise. Basically just trying to improve the layout of our workspace. This section I think looks okay. I've collapsed it and we're not too interested in what each transformer is doing, so that's fine. What's going on over here? We've got kind of a step ladder thing happening here. I like to just get everything lined up on the top, and I'm using my guides to do that there. Try to line this one up as well. Neighbor finder, maybe we'll move up a little bit. Can line these up with the ones above. Probably move this so my connection line is straight. And I will move these last three transformers as well. I guess my creator, my feature reader, they're not really feature types, but if you want to keep the same pattern, you might put them over here as well. This is kind of a personal preference thing. I just like to have everything I'm reading over the left. It tends to make these long connection lines, but I just like to know what I'm getting read in. You might want to put that later in the workspace. It would be a little tidier. But now since I have this big connection, well, maybe what I'll do is I will just hide that and know that it's going over there. So that looks pretty good. I've got all my sections. So why don't I section these up now with some bookmarks? I'd say that maybe what I'll do actually is I'll put these in one bookmark here. This is going to be calculate crime value. I'm going to label, just use an annotation to label my feature joiner. Join crime data to addresses. And you can do things like this, use bookmarks, but then leave some out if you want, and there's nothing wrong with that. Or, I could say maybe this actually is included in calculate crime value. And maybe I don't actually even want to label everything in it, so I just collapse it like that. You could do that if you like. Down here, could probably move these up a little bit. All right, this is the pool, the neighbor finder is the pool, so I don't want to put that in the crime value one. What I probably want to do is put it down here in a pool distance bookmark. I think that would get included in there as well. What is this one doing again? This is, oh yeah, the noise control area. So that's kind of its own thing. So put that in here. And then at the end here, I guess you could say calculate, oops, walkability. And within that, if I wanted to, I could say that this is clean up attributes, or you could be more specific. You could say remove unneeded lists or something. Calculate walkability. So I won't go through all of this. I'll give everyone a moment to kind of do it to their own workspace, but that's kind of the idea. And you could do this as is obvious here. You can do this in a lot of different ways. Your final result will probably look quite different from mine. But the goal is to just make it clear what's happening. Put your bookmarks in sections so that you can view easily what's going on in each section of the workspace. Whoops. So let's see if I missed anything here. Yeah, not really. So that's basically the point of this exercise. So I think we do have a bit of time left before we move on. So I'll probably give everyone a few moments. Go ahead and try to arrange your workspace in a logical fashion. So get your bookmarks in there, annotate everything. You can collapse bookmarks if you want. So go ahead and take a while to do that. And then what you should probably do is open up the end workspace, or I guess you can use this image if you want to just compare to see, how did you set it up versus how did we set it up in this example, because you can use that as kind of an idea. Did I do a good job? What choice did they make versus what did I do? Okay, so hopefully everyone had a bit of time there to try out applying the style guide to their workspace. I'll go ahead and open up the completed version, which some of you might have already been referring to, just to show you one example of how you might have done that. I did a sort of quick sloppy version earlier. This would be a more finished one. So you can see the choice here was to actually have readers in separate bookmarks, but have them be color coded. They used a vertical stacking sort of arrangement to keep everything compact. You see some user annotation when it's sort of needed to really explain what's going on somewhere. We have some nested bookmarks as well. So for the swimming pools one, they've put the reader inside there. This is an important one to remember because we learned that lesson the hard way. So they've kind of made sure future users know why that's different and maybe not expected. They've got some transformers outside of bookmarks again, which is okay. If you don't think they deserve their own section, you can always do that. Yeah, so that's one way of doing this. Again, there's many. That might be what yours look like. You could do it many different ways. But the important thing is be consistent, make sure someone could open it up and get a sense of what they're looking at. Thanks for taking the time to be with us today to learn about best practices in FME. Hopefully you have a bit of a better idea now of how to create efficient workspaces that will be easily shareable with others, and also some techniques for debugging if you need to figure out what's going wrong in your workspace. Take a few moments to answer these 2 questions for the quiz. Again, this is just for review's sake. Maybe since there's only 2, I'll walk us through it. Which of the following are methods for creating a bookmark? So I went through several of these. They're all mentioned in the manual. Let's see, so click Insert Bookmark button on the toolbar. It does appear that there's an Insert Bookmark button. Could click that. There you go. So that's one way. I'll check that. Select a transformer, right-click, and choose Create Bookmark. That also works. Select multiple transformers and create a bookmark. Yes, that also works. And use the Control-B shortcut. Aha. Let's check our answers. There you go. You can do all four. So I think I pretty much just use Control-B because I like to be able to use the keyboard, but any of these are valid. It's possible to disable other objects besides connections. Can you pick out which of these objects can be disabled in Workbench? So we've seen a couple already in the training this week. Today, we disabled a feature type. I believe earlier in the week, maybe on Wednesday, I think we might have disabled a transformer. Now, what about annotation and bookmarks? What do we think? Right-click. Don't see a disable on the annotation, so that's not good. What about bookmark? Well, we do have a disable all objects in bookmark. So, sort of. I'm going to check it. Yeah, this one might be debatable. So that one, of course, you can disable the objects in a bookmark. You're not disabling the bookmark itself. So you can click show an explanation, and then we cop to that. Technically, you can't disable a bookmark, but you can choose to disable all the objects within it. That makes sense. So that wraps up the best practices training for today. I'm going to leave this exercise 4 for a moment. I'll come back and explain that. But before I do that, I do want to do a course wrap up. And so I'll do the wrap up, get some housekeeping, point you in some directions for future training and resources, and then I'll come back and introduce exercise 4, and you can work on that between 11:30 and noon, and will be available on chat if you would like to give it a shot and have questions. So here are some resources that you might find useful. Of course, there's safe.com, easy to remember. This is our website if you want to browse that to learn more about FME and the solutions we provide. A lot of good information on there about industries and specific customers we've had, how they've used FME. I personally obviously don't work on the support team here, but I work closely with our FME experts, and I'm always amazed at the lengths they're willing to go to help people solve their problems. So if you're having trouble, definitely get in touch with them or your local partner if you're based internationally. They can also help you with purchasing the software or also provide services. You can get in touch with them at our partner page, safe.com/partners. My colleague Mark, who's on Q&A today, writes a lot of the posts on the Safe Software blog. He provides great sort of introductions to new features, overviews, ways people are using FME, often some fun things, slightly unexpected ways to use FME, and tips and tricks. You can view the FME documentation. I'll show you this page here, now hosted on our knowledge.safe.com. This has all the different forms of support you might need for the FME data integration platform. So we have desktop, server, and cloud documentation on here, as well as some technical reference documents, and you can find pretty much everything you need on there. The knowledge.safe.com generally, the FME community, is a really great, useful resource. There's a forum, so you can sort of like Stack Exchange style. You can ask other users for help. There's an ideas exchange where you can suggest ideas to help improve FME. We had one today, maybe that would be one. I don't know. It would be a bit tricky, but the one of it automatically filling in attribute values, that could be something we could look at for certain transformers that don't already do it. There's a knowledge base where you can view how-tos and tutorials. And there's the FME Hub, which we've mentioned before, where you can get your own new transformers or upload them and share them with others. And there's some other links on here as well to even more resources. And you can also search the community on here. That's a great thing to do if you're a specific transformer or even use case you're trying to do. Give it a search on there to see if you can find something for it. We do have a free 30-day trial, which you can try out if you don't already have a license. And we have a FME YouTube channel as well, where we post videos pretty regularly. Tutorial videos go on there as well. Before I go on to the feedback, I would also just point out two more sections on the community, which would be training and webinars. So safe.com/training, you've probably already seen it since you ended up here, but just to highlight some of the other courses we have. Now that you've taken basic, we are offering an advanced course in a few weeks. We definitely say you don't have to immediately take the advanced course after taking basic. In fact, it's usually a good idea to wait a little bit and use FME for a while before moving on to advanced. Some of these topics are helpful, but they're definitely tricky, and they're definitely, some of them are kind of specific. So we usually recommend take basic, work with FME for a while, and then take advanced. But if you're a real keener and you can get the time from work, then go ahead and take advanced coming up pretty soon. And then also this summer, we'll be offering FME Server REST API, authoring, and administration courses throughout the year. And all of these will be recorded and posted to the videos and manuals section when the videos are ready. I would encourage you to please fill out the feedback form if you have not done so already. I will chat that out now. That just lets us constantly improve our training. As I said, this is the first run through of Desktop Basic for 2019 since this version of the software just came out, and we've changed some things around as normal. So would love to hear your feedback on how you think the course went. And everyone should receive a certificate emailed to you if you've been logged on for the duration of this course. If you don't receive it in a week or two, then go ahead and shoot us an email to train@safe.com, and we'll make sure you get that. These are some plugs for the courses. If you want a little bit of a quick description, you can check those out. And overall, I would just like to thank you for joining us this week for Desktop Basic. I hope the course was useful to you, and it will be an asset as you move forward to continue to learn FME and to use it. I'm going to go back to the exercise 4 now and just introduce this before signing off of the audio. So this is a exercise that will basically help you walk through a few of the things that we talked about today. It's also a bit of a nice wrap-up exercise because it does involve skills that you've been using all week in terms of making a translation, building a workspace. And it particularly involves ways of debugging and also just improving your workspace by inspecting and making changes. The conceit is that there's an FME hackathon being held in Vancouver, and you've been invited to take part. And you decided that your project was going to be, well, let's get a little workspace that'll map the route to the cafe where we're going to go after the hackathon. So already thinking ahead, wanting to map a little route to a location from where you're holding the hackathon. And so what you'll do is calculate the best route from the convention center to the cafe, and we're going to write that out into GPX format. Because of course it's a GIS hackathon, so people they're not going to be using Google Maps. That's passé. They're going to put it into their GPS device and navigate there. So that's kind of the conceit of exercise number 4. If you have time and you want to stick around for a little bit longer, you can go ahead and work through that. The answer, quote unquote, is in the end workspace location shown there.